We selected the United Nations Sustainable Development Guidelines of 15 Life on Land, and more specifically 15.3, which aims by 2030 to restore degraded land and soil, including land affected by desertification, drought and floods, and strives to achieve a land degradation neutral world. This is a crucial guideline for the world to achieve to help with flow-on effects to a multitude of other SDGs. The key measure for this is the amount of land cleared by total land area, a measure which is not showing improvements since the implementation of the UN SDGs in 2015. In 2019, over 100 million hectares of land was lost per year, mainly due to deforestation for agricultural purposes. We are projected to lose 1.5 billion hectares of forested land by 2030 if more controls are not put in place. However, just reducing deforestation will not turn back the clock on desertification. To meet the UN SDG targets, over 1 billion hectares of land will need to be replanted to combat rampant desertification.
Human activities can set in motion both droughts and floods on land through various means. The reduced land capacity to soak up rainwater due to deforestation heightens the risk of both droughts and flooding, particularly during heavy precipitation periods. Urbanization causes runoff, resulting in urban flooding and heat islands that worsen droughts by replacing natural, permeable surfaces with impermeable ones. Over-irrigation and the use of agricultural chemicals can diminish water supplies, leading to both droughts and flooding. If not managed properly, dam construction can exacerbate both situations. Human-induced climate change alters weather patterns, increasing the probability of both droughts and floods. Droughts and floods can also be initiated and intensified by desertification, a natural process driven by environmental factors. Desertification's severity can be influenced by natural climate fluctuations like El Niño and La Niña, leading to prolonged dry periods or excessive rainfall. Another natural process contributing to desertification and heightening flood risk downstream is erosion, driven by wind and water forces. Alterations in vegetation and geological processes also impact desertification. Importantly, human actions often worsen desertification, creating a cycle of droughts and floods, as mentioned earlier, in combination with the natural phenomena.
Reduction in rainfall is an occurrence that cannot be completely explained, but it is known that human interference can increase the rate of climate change and may evidently cause a lack of rain. This, paired with the overuse of water storage and aquifers for agricultural and consumption uses, causes the availability of fresh water levels to decrease, therefore drying out soils and leaving the environment open to desertification. Chemical use in these human activities have the possibility of leaving small amounts of trace elements in nearby water and soil. Over time, this buildup becomes more evident as soils begin to lose function and dry up, allowing only adapted plants to survive with higher concentrations of trace elements, in particular heavy metals. Furthermore, this causes a flow-on effect by contaminating water and allowing these trace elements to continue to cause more harm to the environment. The overall consequences feed into other SDGs as contaminated water and soil kills or contaminates flora and fauna, which in high concentrations cause illness and death.
There are at least 3 ways in which the SDG can be connected to molecular biology. The first way is through understanding plant adaptation. Molecular biology can help us understand how the genetics of certain plants help them adapt to arid conditions. Schreiber et al. 2017 states that there is a growing body of work focusing on identifying molecular bases of natural selection and how variation in specific allele loci can be connected to how adaptive certain plants can be to selective environments. The second way that molecular biology can connect to these SDGs is through an understanding of soil microbiology. Molecular biology techniques can be used to study how the microbial life in the soil plays a significant role in maintaining its health and fertility. Maintaining a healthy and fertile soil in arid and semi-arid conditions is key in combating desertification. Schreiber et al. Also mentioned how microorganisms are the key players in the cycling of nitrogen, sulfur, and phosphorus, as well as the decomposition of organic residue. Being able to analyze microbial life in arid and semi-arid conditions is therefore key in understanding whether the soil is healthy or initiating change if it's found the soil is not. The third way that molecular biology can connect to these SDGs is through bioindicators. Leo et al. 2021 discussed ground beetles diversity and how changes to that can be one of many bioindicators that a land is likely to become desertified. There are also certain arthropods, such as mites and springtails, which are very sensitive to changes in environment, so changes in their numbers or health can also function as an indicator of likely desertification. The UN has a number of initiatives to combat desertification and restore degraded land and soil. These include a scientific framework for land degradation neutrality, which was designed specifically to create a bridge between the vision of achieving land degradation neutrality and its practical implications, given its key role in achieving the target of this SDG. A similar practical tool also by the UN is the Sand and Dust Storms Toolbox. Again, this aims to both develop and implement strategies to monitor, forecast sand and dust storms and develop and implement ways to mitigate their impact. In terms of how microbiology can help combat desertification, a study by Rossi, Liliu, and Phillips 2017 discussed how one way to affect soil microbiology is using biocrusts. These are complex communities composed of different proportions of cyanobacteria and other microorganisms capable of affecting the stability and quality of arid and semi-arid soils. Cyanobacteria are the primary colonizers of bare soils in many of these environments, and it was recently applied over a desert in China by seeding large sand dunes with selected cyanobacterial strains. In certain previously deserted areas where cyanobacterization has worked, the land moved from being sand without photosynthetic organisms to areas where lichens and mosses colonize and dominate the community. Finding an effective way to combat desertification and restore degraded land and soil is key not only to achieve the SDG we spoke about today, but also because it relates to so many of the other SDGs some of you will be talking about, such as climate action, clean water and sanitation, no poverty, and most importantly, zero hunger.